Welcome back to our course on blockchain and its applications. So, in the last classes we have seen about the models for consensus in a permissionless setup or in an open blockchain network, and by this time you have also learnt about the Ethereum, the permissionless blockchain platform, and you got an experience about how you can develop decentralized applications on top of Ethereum permissionless blockchain. Now, today we are going to move towards the consensus models for permission blockchain. So, we are going to see that how we can achieve consensus in the context of a permissioned blockchain model, and we will see the different way we can develop the consensus architecture for a permission blockchain network. Now, to start with, the concepts that we are going to cover today are this basic idea of the permission model and the concept of state machine replication, which is applied thoroughly for the development of the consensus model for the permissioned blockchain network. So, these are the keywords consensus and the state machines that we are going to discuss today. So, to start with, let us have a brief background about this permission model. Earlier we talked about the permission model, have given you an idea about what permission model means and what type of application can be supported on top of a permission model or a closed blockchain model. So, basically the permissioned blockchain model is a blockchain architecture where the users are authenticated a priori. So, what does it mean? It means that it is a kind of closed network. So, what we have seen in case of permissionless blockchain architecture, that it follows a kind of open network. So, anyone can join in the network, you do not need any kind of pre-authentication or pre-authorization to join into the network. Now, in contrast, in case of permissioned model, I need the users to be pre-authenticated. So, the user should have certain authentication mechanism through which they get authenticated before they join to the network. So, that means the authentication mechanism or an authentication server controls the joining and the leaving of a network. And we have something called a membership service provider or MSP. So, a membership service provider basically provides the interface through which a node or an person or an entity can receive the authentication key and can get validated itself as a valid member of the blockchain network and can join in the blockchain network by using the corresponding authentication mechanism. So, this membership service provider, it helps the individuals to obtain the membership in the blockchain. So, in a permission model, because it is a kind of pre-authenticated and pre-authorized network, everyone knows who are the other participants. Well, so that is the kind of advantage that we get in case of a permission model or permission blockchain architecture. So, in contrast to the permissionless model or the open model, where our major problem was that the users do not know each other, because the users do not know each other, that is the reason we could not use the message passing interface to communicate between the individuals. We relied on a gossip based architecture and a challenge response kind of platform to achieve consensus. But here the advantage that we have is that the users know each other. But interestingly, although the users know each other, they may not trust each other. So, that means the participants who are there in my blockchain network, they are kind of competitor to each other. Well, so that is something interesting. So, the example use cases that I have mentioned to you earlier, if you try to remind them, we talked about different business enterprises where multiple enterprises comes to a common business, they have a kind of common goal that they want to achieve. So, consequently, they are kind of competitor to each other. So, for example, if you are going to a supply chain marketplace, in a supply chain marketplace, individuals are competitors to each other. Now, when individuals are competitors to each other, they do not trust each other, because I would always like to maximize my profit. Now, when I would like to maximize my profit, what might happen that, well, in that means I would try to ensure that, well, you are not gaining that much of profit. I would do better in my business compared to you. So that way there is always a kind of competition there. Well, so if I get certain information from your site, I might get advantage in setting up my business accordingly. So that way the users may not trust each other, user may not believe that whatever information has been provided by their competitor, that information is genuine. So that is the reason we still require security and consensus in case of a permission model. So that is the kind of broad motivation or a kind of broad idea about why do we still need consensus in a permissioned blockchain model. Although in a permission blockchain model, the users or the participants, they know each other a priori. So what we are going to do at the end of the day in a permission model, that we are going to run this blockchain service among known and identified participants. So that means the individuals who are there, they are known and they are identified. So say some nodes they construct a network. So the participants in that network, they know each other, but interestingly they do not trust each other. Well, so that way I still run a kind of blockchain service in this architecture, but while running this blockchain service in this architecture, I still need to ensure a way of consensus or a way of ensuring security in the platform. Well, so that is the kind of my entire premise based on which we try to develop this permission model or try to develop this permission blockchain architecture. So as I mentioned earlier that this permission blockchain model is particularly interesting for different types of business applications. Well, so basically you want to execute contract among a closed set of participants. Now whenever you are going to execute certain kind of contract among a closed set of participants, and these participants are kind of your competitors, then you cannot rely directly on the information provided by them, because it might always happen that your competitor is providing certain kind of false information to deceive you. Well, so users may behave maliciously. So that kind of things can always happen. Because such kind of things can happen, we need certain kind of consensus mechanism to ensure that whatever information is getting added to the blockchain, that information comes through an agreement of the majority of the participants. So people agree that this particular information is a valid information and that can be added to the blockchain. So that way we need certain kind of agreement protocol to ensure the consensus. So one of the prominent example that can be there in case of permission model that we mentioned earlier as well is the provenance tracking of assets in a supply chain. So earlier we discussed about this supply chain management architecture. So here we are just having a figure of a kind of supply chain from the grocery domain. So where the vegetables, they are produced by the farmers, and then these vegetables goes to the wholesalers they distribute it. So it goes to the distributor. Now through the distributor it finally reaches to the market from where you are going to buy the vegetables. So that way these vegetable products or the grocery products which are floating in the market, they comes through multiple middlemen and multiple stages in the supply chain pipeline. Now in this case we have multiple distributors, multiple wholesalers, well different cold storage which are going to store the vegetables in between. So that way I have a large number of players who are participating in this entire end-to-end supply chain. Now when I have such kind of large set of participants in the end-to-end supply chain, I obviously need to ensure that whatever information they are providing, those informations are correct and a kind of valid information. So that way what I can do, that all the players who are the part of this entire end-to-end supply chain, I can possibly bring them to a common platform, common coordination platform with the help of blockchain, where they can possibly share information among themselves in a reliable way and can make overall benefit from this supply chain management architecture. They can easily understand the demands and supplies and accordingly can make planning that, well, I need to buy this much of potatoes from here and sell these potatoes to there. So that kind of coordination among different kind of stakeholders can be done by applying a kind of coordination mechanism with the help of blockchain. So, that way for such kind of use cases, blockchain under the permission model is a perfect use case that we can possibly think of or we can possibly apply. Now, the question comes that what we are going to do within a permission network. So, in the context of permission network, earlier I have mentioned about this smart contract. So, here is a kind of formal definition of smart contract. So, a smart contract is basically a self executing contract which the terms of agreement between the buyer and the seller is directly written into the lines of code. Well, so this definition have been taken from this scalableblockchain.com site. So, according to this definition, a smart contract is basically used to automatically execute and validate the contract between a buyer and a seller. Well, so the question comes that, well, such kind of agreement. So, if you think about a typical supply chain management architecture, so in a typical supply chain, I have multiple different stages of buyers and multiple different stages of sellers. Now, if I can make a kind of agreement among this buyer and seller with the help of this smart contract, then I can possibly make the system more transparent and can track that what is actually happening in the global supply chain architecture. So, that way such kind of smart contract architecture are very useful and very important in the context of blockchain. So, the question comes that whenever we are executing such a smart contract on a closed network, how can I come to an agreement on the smart contract execution? Well, so this can be the possible steps. If you remember that earlier we discussed about these steps as well. Today we are going to expand these individual steps and going to learn that what is happening in between. So, whenever you are going to have certain kind of agreement on a smart contract execution, so these are the steps. First, you store the contract on a blockchain. Now, once a particular event is triggered, then you execute the code locally on each peer. Well, so this part is important, that when I have certain kind of event, say for example, certain amount of goods have been delivered from the seller to the buyer, or the buyer has transferred the corresponding money from its bank account to the seller's bank account. So, such kind of event when it gets triggered. So, when such event gets triggered, based on the event which is happening, you execute the smart contract locally at each peer or at each participant. Well, and once you are executing this transaction, so whatever be the output of this code, against that you can generate transactions which looks like the output of those contract. Well, say for example, the output of the contract is saying that, well, that seller has transferred 20 tons of potatoes to the buyer. So that is the kind of event which has happened. Now, when that event has happened, so you can generate a transaction saying that, well, 200 tons of potatoes have been transferred from seller A to buyer B. Well, so that way you can represent it in the form of a transaction. Now, the peers of the blockchain network, they can validate this transaction, they can find out that whether this particular transaction is a valid transaction or not, and if it is a valid transaction, then the output can be committed in the blockchain. Well, so that means whatever the decision has been made, that, well, you are transferring this much of potatoes from buyer A to seller B, and against that maybe the seller need to trigger the transfer of the money from its bank account to the buyer's bank account. So, to do this kind of automated triggering, we commit the previous transaction in the blockchain, and whenever you are committing the previous transaction in the blockchain, so this kind of commit operation may trigger the next event to execute on the code. Well, so that way we can take help of a blockchain, we can run the contract in a intermediate way. That means, when certain intermediate events have been triggered, based on the particular event, you execute a part of the code, and the part of the code that have been executed by you, you store that the output of that part in the blockchain. Well, so that basically ensures that well the other people, other participants in the network, they can validate this particular transaction, they can execute the same piece of code, because remember that you have stored the contract on the blockchain itself. So, the blockchain has a piece of the code. So, that way the others will be able to validate that piece of the code, and they can see that whatever output has been claimed by the receiving party, that particular amount is correct amount or not. Also, so that kind of validations can be done here. Now, the question comes, the important question comes that what I mentioned earlier, that once an event is triggered, you execute the codes locally on each peer. So, in the context of blockchain based smart contract, the specific question that we have is that do we really need to execute the code on each peer? Well, and when does each peer executes the code? Also, so possibly the answer of this second question is already available to us. So, what we have seen that well, when a particular events get committed in the blockchain, that might possibly generate the next event. So, for example, when you have transferred the money corresponds to the first block of potato transfer, then the sellers can find out that well this particular buyer is loyal and that buyer has transferred the corresponding money. So, I can possibly start sending more amount of potatoes or try fulfilling the demand way further. So, that way depending on such kind of triggers the peers execute the code, but we still do not have the answer for this first question. So, the first question says that do we really need to execute the code on each peer? Well, so is it like that well I have submitted a smart contract and in my blockchain network currently there are 100 peers. So, is it like that those 100 peers everyone need to validate the code? So, that is the problem that we have, and let us see that how we can actually solve this problem. So, what we can do that we can execute the contract on a subset of nodes and ensure that the same state is propagated to all the nodes. So, what does it mean? It means that you may not want to execute the contract on each individual node, because everyone are in the same pace. They can see that well the code have been submitted in the blockchain as well as the corresponding intermediate executions which have been done till now, they have also been executed in the common blockchain kind of interfacing platform. Well, now when you see that such kind of information has already been entered, that will possibly trigger the execution further. Well, and that way what I can do that this particular smart contract that I can execute on top of a subset of nodes, and I can ensure that the same state, that state that have been generated after executing the contract on my local machine, that state is propagated to all other nodes. So, we can reach to the consensus on this state of the node. Well, so that is my requirement, that majority of the majority of the peers should agree on that state. And then comes the second part, that well majority of the peers should agree on the state. They may agree on the state, and we know that by virtue of digital signature what I can do, that I can possibly, if I am agreeing to a particular message, I can sign that message with my signature, which makes me a witness to that proposal, and the proposer can claim that hey, this particular information have been signed or have already been validated by majority of the participants in the closed ball blockchain. So, this is a kind of valid information that can immediately be committed in the blockchain. Well, now for this validation purpose that is being executed an individual node. So, earlier we have seen that for such kind of problems generating the proof would be tougher, and generating or validating the proof would be much more easier. Well, so that is the kind of requirement which I have. So, I need to generate certain kind of proof that will say that well I have attested or I have signed this particular message and I am taking part of this agreement protocol, and this validation or this particular proof ensures that a peer has agreed on the state of execution for this blockchain. Well, so this is the kind of particular requirement from the smart contract side. So, so the question comes that how will we generate this proof? Well, the proof that is going to ensure that the contract have been executed and validated by the majority of the correct participants. Now, to generate the proof, we actually comes to this fault tolerant architecture, and what we do that we represent the smart contract in the format or in the form of a state machine, well, and apply this classical distributed system idea which is called the state machine replication. So, we will see that how state machine replication is important in the context of a blockchain. So, to discuss about the state machine replication, the first point is that we or our primary objective here is to represent the smart contract in the form of a state machine. Well, so the question comes that how we can represent a smart contract in the form of a state machine. So, from your undergraduate course of algorithm and programming, you already know, and we mentioned that earlier too, that any deterministically executable code can be represented in the form of a state machine. Well, so when any deterministically executable code can be written or can be represented in the form of a state machine, that basically means that the smart contract that I have, so this is my smart contract. So, what I can do that I can possibly convert that smart contract in the form of a state machine, and then I will execute that state machine to ensure consensus among different participants of the node, well, different participants of the blockchain. So, let us see further that how we can apply state machine replication for achieving this blockchain consensus. So, here is an example, here is a simple state machine. So, I have a code here that what the code is doing, that the code is checking whether I have more amount of goods. If I have more amount of goods, I will keep on delivering the good. Once I am out of this state, that means I have delivered all the goods. Then I will check whether all the orders are complete or not. If all the orders are complete, then you go to state 1, well, to find out that whether you still have more amount of goods to transfer, and after that once you have transferred all the orders, then you mention or you print that good transfer is complete and you reach to the final state. So, this is the kind of state transition diagram that we have. So, if you just try to match with this diagram, you can see that well, here I have this state 1 which is the initial state. Now, at this initial state I am checking whether I have more goods. So, if I have more goods, I will remain in this state, otherwise I will deliver the goods, well, when I state will become 0. Now, after I have delivered the good, that means I have reached into state 2. So, whenever I am at state 2, I will check whether all order are complete or not. If all order are not complete, then I would move back to state 1, well, and if all order is complete, then I will move to the final state, and the final state says that all orders are complete. Well, from S2 I move to that final state. So, that way any such kind of deterministically contract can be represented in the form of such type of state machines, and as we have seen earlier that blockchain is nothing but a state machine. Well, so let us see that how we can execute codes on top of this state machine. So, in state machine replications, what happens that the state machine that I have, that state machine is replicated to individual server, and once the state machine is replicated to individual server, then individual clients can submit their transactions. So, here one client is submitting the transactions to one particular server, saying that I have delivered 100 kg of potatoes, and then another client submit another transaction saying that I have delivered 50 kg of tomatoes. So, now you have two different transactions T1 and T2, and these T1 and T2, these two transactions need to go through the consensus mechanism. Well, so how this consensus mechanism will work? So, the consensus mechanism will work in this way that, well, first I need one node in the system that will order the transactions, that means which particular transaction will execute first, whether T1 will execute first or T2 will execute first. So, accordingly I would come to a consensus mechanism on the transaction ordering, and this particular transaction ordering will ensure that every replica that I have or every backup that I have, all the backups are on the same page and all the backups are agree on the same order of the transactions. So, accordingly say all the replicas agree on the order of T1 followed by T2, that means T1 would be executed first and then T2 will be executed, and accordingly the execution starts, and in this stage every independent machine or every independent server, they start executing the transactions on the their local state machine. Well, so everyone will first execute T1 and then they will execute T2. So, when this execution is happening, during that time after this execution is over, then this individual node they will reach to certain state. So, assume that after both of these transactions have been executed, they reach on state S2. Well, now once they are reaching on state S2, then they will come to a consensus on this final state, that, well, everyone will say that I am at state S2. So, this is the model, this is the way the state machine replication work, that the state machine that you have, you replicate it in all the servers that you have, and when you have multiple such different servers, you execute the transactions on those individual servers, and after you have executed it on individual servers, then you collect the final state and come to a consensus on that final state. Now, once you have reached to this final state, then one of the machine can actually inform the client that, hey, after this execution we have reached to this particular final state. Now, the challenge come here. The challenge is that if one of the state machine becomes faulty, well, so here assume that this particular state machine becomes faulty, and when others are saying that they have reached into the consensus state at S2, it says that, hey, I have reached into the consensus state of S3. Well, and particularly because of this reason, we need a distributed message passing based interface through which such kind of consensus can be ensured, saying that, well, we will go for certain kind of majority voting. So, here I have 3 different servers or 3 different replicas. If you take a majority voting, you will find out that, well, based on the majority voting they agree on S2. Well, so the final consensus state is S2. So, in conclusion, what we have seen today that, well, we can possibly utilize this state machine replication based architecture for smart contract execution on a closed blockchain network or on a permission blockchain network, where you represent your smart contract in the form of a state machine and then replicate the state machine into individual nodes, and then these individual nodes they execute the state machine locally and come to a consensus by exchanging messages among themselves. Well, but the question comes that here that how can we extend this kind of state machine replication model for designing the consensus algorithm for permission blockchain. So, in the next class we are gradually going to learn that, well, such kind of state machine replication based consensus algorithm, they are kind of very prominent consensus algorithm for the distributed consensus, and we can utilize this architecture, such kind of state machine architecture, to finally reach to a consensus on a closed environment by applying the traditional distributed consensus algorithm. So, in the next lecture we will start discussing about those distributed consensus algorithms. So, thank you all for attending this lecture. We are going to meet again in the next class.